class. Tonight we are going to add 2 more properties to our exponents properties. Tomorrow we're going to create a foldable that puts all of our properties together. But the section is 8.5. It's the division properties of exponents. Okay, let's go ahead and take a look at this example. In all of our examples last week, we used repeated multiplication to help us find the shortcuts or the properties of exponents. We're going to do the same tonight. If we are looking at a problem 5 to the 6th divided by 5 squared, notice that it is a division problem because we are dividing 5 to the 6th by 5 squared, and it's a division problem of exponents because we have an exponent of 6 and an exponent of 2. We also have the same base because each of the bases of the powers are 5. Well, to use repeated multiplication, that just means expand the power using the definition of an exponent. So 5 to the 6th means that 5 is multiplied by itself 1, 2, 3, 4, 5, 6 times. 5 squared, of course, means that 5 is multiplied by itself 2 times. Well, how are we going to simplify this expression? We all know the most basic idea of division is that if you divide a number by itself, so 5 divided by 5, that the quotient is 1. So we can divide 5 by 5, but 5 by itself 2 times, and each of those quotients are equal to 1. So then what remains? Well, what remains is 5 times 5 times 5 times 5, or 5 to the 4th. Okay. I'd like for you to pause the video, all right? And I would like for you to do the second example, and then press start. Okay, all right, so we see a to the 3rd divided by a to the 5th. We know that a to the 3rd is a times a times a, and a to the 5th is a times a times a times a times a. Again, using the idea that dividing a number by itself has a quotient of 1, we are left with a over a to the 3rd. Not really, because we have 1 more that we'll divide out. We are left with 1 over a squared. But thinking back to what an exponent means, if we wanted to, we could rewrite this as a to the negative 2nd if we wanted our base to be in the numerator. So what I'd like for you to do is take a look at the 2 examples, a to the 3rd divided by a to the 5th, and 5 to the 6th divided by 5 squared. Is there a way to bypass writing out the repeated factors so that we could end up with 5 to the 4th and a to the negative 2nd? Okay, is there a shortcut? Do you see a shortcut? Okay, well, here we are. To divide powers with the same base, the shortcut is that we can, and I'm sure you were thinking of it, subtract the exponents. So if we have a to the m divided by a to the n, the quotient is a to the m minus n. Again, this only works if we have the same base. Okay, and the base is a. The other thing that I need to point out is that we are going to assume, because we can't divide by 0, that the denominator, that the denominator is never equal to 0. No base is 0. So our shortcut is to divide powers with the same base, you subtract the exponents. Let's do some practice problems. What I'd like for you to do, I think I have 5 problems here. I want you to simplify the following expressions and write your answer using only positive exponents. All right, so I have 5 problems. All right, I'd like for you to write these down and work through them. And then go ahead and write those 5 problems down. And then when you've attempted them, go ahead and press play. Okay, so letter A to the 6th divided by a to the 14th. I recognize that both of the powers have the same base, and then I'm dividing. So I know that this will simplify to a to the 6 minus 14. Now, you may not want to write this intermediate step that I'm writing, and that's perfectly fine. So I'm left with a to the negative 8. Every time we use this rule, the power automatically, okay, will be in the numerator, always, every time we use this rule. If the exponent is negative, then I need to move that negative power to the correct side, to the appropriate side of the fraction. So this simplifies to 1 over a to the 8th. Letter B, n to the 11th divided by n, and k to the 5th divided by k squared. I like to think of this almost as two separate problems. N to the 11 minus an understood 1 is n to the 10th. K to the 5th divided by k squared is k to the 5 minus 2, or k to the 3rd. Now, there's no need to rewrite this or to write it as a fraction over 1. So I would leave it as n to the 10th, k to the 3rd. Okay. All right, part C. C to the negative 1, d to the 3rd, divided by c to the 5th, d to the negative 4th. The rules still apply even with negative exponents. C to the negative 1 divided by c to the 5th is the same as c to the negative 1 minus 5. I'm subtracting the exponents, multiplied by d to the 3 minus negative 4. I think it's really helpful to write this step out because it's easy to make it a very simple sign error. So this simplifies to c to the negative 6 times d to the positive 7. Because I want to leave my answer using only positive exponents, I'm going to go ahead and leave d to the 7th in the numerator, but move c to the negative 6th to the denominator. Once I move it, notice that the exponent is positive. All right, on D, looks like a little trickier here. Okay, the powers are not aligned. So I'm going to use alphabetical order. This will simplify to f to the negative 4 minus 6 times p to the 3 minus negative 3. Okay, well that is equal to f to the negative 10th times p to the 6th. And then to finish up, I have p to the 6th divided by f to the 10th. All right, last problem. All right, we have 3 different powers that we're working with. First thing I'm going to do is align this. If you have different colored pencils, that might be a great idea to underline each of your like bases. If you don't, you could do 1, 2, and 3 lines. I'm going to start with x's, okay? And understand that anytime you see a variable, that it has an understood exponent of 1. All right, so I have x to the 2 minus 1 times y to the negative 1 minus 4 times z to the 4 minus negative 3. So to simplify, this will be x to the 2 minus 1 is 1. I don't need to write that exponent. Y to the negative 1 minus 4 is negative 5. And z raised to the 4 minus negative 3, which is 7. Okay, I don't want to leave any negative exponents, so the power that gets moved to the denominator will be the y to the 5th. X times z to the 7th remains in the numerator, and y to the 5th moves to the denominator. Okay, we have one last rule. Okay, and this is raising a quotient to a power. What if we have a quotient, which is the answer to a division problem? In this case, it looks like a division problem. It is a division problem. X divided by n, quantity squared. Using repeated multiplication, what would this look like? What would look like x to the n times x to the n. And even though they are 2 separate fractions, It has the exact same meaning as x times x divided by n times n, all in the same fraction. Well, we know that this is equal to x squared divided by n squared. Okay, go ahead and write this example down, or write this problem down. I'd like for you to expand it, pause the video, and expand it and see what it simplifies to. Okay, so we have a over b times a divided by b times a divided by b times a divided by b. Okay, so I can look at this as one big problem. Okay, the a is in the numerator being multiplied by itself 4 times. Okay, so by definition of an exponent, that's a to the 4th. And b is multiplied by itself 4 times. So this simplifies to a to the 4th divided by b to the 4th. All right, do you see a shortcut? Again, how do we get from the original expression to the final expression without showing the repeated multiplication? Okay, so this is our final property, and it is raising a quotient to a power. Okay, so hopefully you recognize that what we can do is simply apply the exponent to each base of the quotient. The n will be applied to the base of a and to the base of b. So we have a property that's called the power of a product, in which we also apply the exponent to each base. It's the same idea, it's just that we're starting with the quotient. So our quotient to a power property is that you apply the exponent to every base in both the numerator and the denominator. If you need to pause the video, please do. Make sure that you get all of this written down. Now we're going to move on and look at some examples to finish up. Okay, so raising a quotient to a power. I have 4 examples here. What I'd like for you to do is practice these, pause the video, write these problems down, and then play the video to check your work. All right, this first example, I am going to apply the exponent to both the numerator and the denominator. So that will give me 4 to the 3rd divided by. Now, I know that I have another property that tells me that if I have a power and I raise it to another power, I must multiply the exponent. So when I raise x squared to the 3rd power, it expands or simplifies to x to the 6th. Because 4 to the 3rd is a manageable number, I can do that in my head. 4 times 4 is 16, times 4 is 64. Okay, I'm going to go ahead and write that as a whole number. Okay, the second example, n to the 9th divided by 2, raised to the 5th power. Well, that's going to simplify to n to the 9 times 5 is 45. And in the denominator, 2 to the 5th. One thing I do want to point out is that the understood exponent on the 2 is 1. So I really am multiplying the exponents here as well, because 1 times 5 is 5. So it's divided by 2 to the 5th. So that will simplify to n to the 45th divided by 2 to the 5th, which is 32. Okay. Third example, y cubed to the 4th will be y to the 12th divided by 3 to the 4th. And 3 to the 4th is the same as 3 squared times 3 squared. I know that 3 squared is equal to 9, so 9 times 9 is 81. Okay, last example here, x to the 4th divided by c squared raised to the 7th. Going to apply the exponent to each and every base. So x to the 28th divided by c to the 14th. All right, so I've got a question. How do we simplify a over b if we're raising it to a negative power? Well, what we would do here, I like to go ahead and apply the exponent first, and then using the property of negative exponents, the definition of a negative exponent, I know that each of these powers belong on the opposite side of the fraction. So I'm going to move b to the negative nth to the numerator, making it b to the nth, and a to the negative nth, I'm going to move it to the denominator, making it there a positive a to the nth. So I'm going to apply the exponent, and then I'm going to move any negative exponents that need to be moved. Okay, I have 3 final examples. All right, 3 over 5 to the negative second, the opposite of 4b divided by c to the negative second, and n divided by 2a cubed, all raised to the negative fifth. Please go ahead and pause your video, work through these problems, and then check them against mine. Okay, with the first example, I'm going to apply the exponent. We'll make this 3 to the negative second divided by 5 to the negative second. I see negative exponents. I don't like that. I'm going to change. I move the powers to the appropriate side. 3 to the negative second gets moved to the denominator. 5 to the negative second gets moved to the numerator, and both lose that negative. 5 squared is 25, and 3 squared is 9. On the second example, when I see this negative, I'm just going to make things easy on myself, and I'm going to apply that to the numerator. So I'm going to think of that number as a negative, okay, negative 4, which is now being applied to the negative second. So I have to be very careful and recognize that I'm taking a negative 4 and raising it to the negative second. B is raised to the negative second, and C is raised to the negative second. I'm going to take care of those negative exponents and move each power to the appropriate side, to the correct side. So negative 4 quantity to the second times b to the second moves to the denominator. C squared moves to the top. All right, the last thing that I need to do is just go ahead and simplify negative 4 to the second. Well, I know that negative 4 multiplied by negative 4, a negative times a negative is a positive. So it is 16 b squared in the denominator. Last problem. All right, n divided by 2a to the third. Well, I recognize that I have 1, 2, 3 bases. So I must apply the negative 5 to all 3 bases. And when I raise a power to a power, I multiply the exponents. So n to the negative fifth divided by 2 to the negative fifth, a to the negative 15. I'm going to move all of the powers to the correct side. So that's going to make my numerator 2 to the fifth times a to the 15th, and my denominator n to the fifth. Now my numerator is 32 a to the 15th, because I know that 2 to the fifth power is 32, divided by n to the fifth. All right, hope you have a wonderful evening, and tomorrow we are going to continue our work with the quotient property and the power of a quotient property.